All right. Hi, everybody. Thank you for joining us today. My name is Juan Pablo or JP. I'm a senior tester here at Sprocket, and today we're going to talk about something I really like to do here, password cracking. We're going to talk about different password cracking techniques, what works for us. We're also going to talk about just weird situations where as pen testers, we got to get creative. And we have a talk coming up at CypherCon this year or next year about transliteration, what that is, why it happens, and how that affects password cracking. So we'll talk a bit about that as well. We'll talk a bit about that as well. But I'll let the rest of the guys introduce themselves real quick, and then we can jump right in.
Good afternoon, everybody, and happy Friday. My name is Nate, and I am a pen tester here at Sprocket. Been here for a couple of years now, and I'm on the service delivery team doing a bunch of fun hacking and stuff like that with all of these other guys here.
I'll go next. I'm Will Van Devender. I'm a researcher. I work on the service delivery team as well, doing pen testing as well as some of the research work. So,
Hey everyone, my name's Justin. I'm one of the penetration testers here on the service delivery team at Sprocket. I've been here for about 2 years. And yeah, happy Friday.
Happy Friday. Awesome. Real quick, just to start off, we'll talk a bit about the talk coming up. So, the talk is going to be about transliteration. Transliteration is the process of representing characters from one writing system into another. And in the context of password cracking, there's two different types. There's phonetic based and keyboard mapped. This is a lot harder to describe without visuals, but basically, I'll start with keyboard map transliteration, which is a lot more common than you would think. Basically, let's say I'm using a keyboard in a different language. Say I speak Russian and I'm using a Cyrillic keyboard. When I type in my password, let's say I'm in Cyrillic mode, but the website doesn't support those characters. So without me knowing, it switches me back to QWERTY. You're going to get what looks like jumbled garbage. And if you can transliterate that back by mapping those key presses to English, then you can sort of figure out what the original password is supposed to be. And this happens in a lot of different places on the internet, especially for password fields, but Google will actually do this automatically. I sent something in the chat. If you Google that and look it up, that looks like random characters to us, for people who speak English. And I'm sure if someone only speaks Russian, that'll also look like random characters. But when you Google that, Google will automatically detect that you typed something in, and even though it's in like the standard ASCII keys, that looks like it should have been Russian. So it'll transliterate that, and it actually only shows you the results for the Russian word, which is super interesting. But this actually happens a lot for passwords as well. So all of this type of research just coalesces into us looking at the Have I Been Pwned database, which is a website that lets you look up passwords that have been leaked from either companies being hacked or any way that passwords get onto the internet. You get to query it to see if your password is up there. So the goal of this was to just find how common are these types of passwords and why they were happening. We did it for Russian, Mandarin, and Korean, and we got some pretty cool results, a lot of interesting passwords. And the reason this is relevant is because when a password gets hashed, it's a one-way function. So the only way to crack that password is to feed it in a measurable number of password guesses, hash them, and compare the two. If it matches, you have the right password. But with transliteration, because this happens and the user might not even realize it's happening or they're doing it on purpose, even if they have a super simple password and that password is in our word list, we're never going to be able to crack the hash because it got transliterated. Now you can raw brute force 10 plus characters if you really wanted to, but a lot of common places on the internet, especially Microsoft, they don't support Unicode for passwords. So you'll realistically never crack it unless you knew to look for it. So that's just one thing that doesn't always come up, I guess, in a pen test, but that's an aspect of password cracking that isn't as well researched or known. And that's something that we get to explore a lot, which is super cool. So we are always encountering different. Yeah, sorry, go ahead, Nate. You raised your hand.
No, I don't want to interrupt. That
No, you're good.
that sounds really interesting. You'd think that I would know a little bit more about that. But my question is actually goes back to the string that you put into the chat. And
Yeah.
you're totally right. I did that, and I was kind of surprised. Is there any way that somebody would be able to look at that string without doing a Google search? Or is there anything that a website can do to tell the end user that the string that they're looking at has been transliterated? Like, how would you
Yeah,
know
so
that?
yeah, and like I said, even if you speak English or Russian, no
Yeah.
one can look at that and just immediately know, oh, that person meant that. I haven't explored as to how Google's doing it. The way we did it for the research was we just mapped every key and we would either feed in an English word list, translate it into the other language. Like I said, we did Russian, Korean, Mandarin. We would either translate that and then transliterate that again just to map it out. How they're
Mm.
detecting it, honestly, I'm not sure. There aren't too many projects that I found on GitHub like related to this kind of stuff. The funniest one I found was like a browser extension that will do it for Hangul, so like the Korean writing system. It was a way of like someone scraped Instagram usernames trying to figure out if someone is like primarily Korean speaking or not by transliterating their usernames. How did that all work and what was the point of that? I don't really know. I'm sure you could build it out eventually if you just start feeding it character mappings for different like password transliterations where you could submit it, it'll compare all of them and try to find it to see if there's like if it maps to a word in that language's dictionary, basically. But yeah, there's not really a good way of figuring that out. And one problem that does come up a lot, especially on like websites, a website could technically take in Unicode, which is just, let's say your password is in Mandarin. And so you're doing Mandarin characters instead of like the phonetic spelling of it. Sure, the website could process it, but when you highlight over the password field, a lot of the times the websites are standardizing it to ASCII and forcing you to only type in characters that are allowed in like a normal, like in a standard QWERTY keyboard. Also, password policies will get in the way too. There's not a lot of punctuation or numbers if you're using a character-based writing system. So oftentimes you can't even put in that password. So that's a scenario where users will forcefully change their password into whatever the default input method is for that website, which a lot of the time is just QWERTY. That happens a lot with the phonetic spelling too. So I had it listed somewhere. So that phrase that I sent in the chat, I don't speak Russian, but it's parol safe or translates to password safe. That's why when you Google that, you got a bunch of Russian YouTube links to like password reviews and also like .ru sites. But if someone wanted to type that password in and all they had was their English keyboard on hand, and the website's forcing them to type in English, or I guess QWERTY, they could just phonetically spell it out like parol safe would be PAROL space SEYF. And that's actually a lot more common. There's a good like research online about Chinese passwords and passwords for people who primarily speak Mandarin. And the comment section was, I and a lot of my friends in Korea will do this too, where what's the main like place that people are typing in their passwords now? It's their phones. So they're typing in their passwords on their phones. Their phones are transliterating it, not on purpose. It's just forcing them to use the English keyboard, but they're typing in the spots that where the Korean keys would be mapped to technically on the standard format.
Ah.
So they're looking at the Korean character, they're typing the Korean character, but what gets input into the password field is the QWERTY version of it. So that happens a lot. Will, you had a question?
Yeah, sorry, I don't want to take you off the path because this is
No, it's
pretty
all good.
cool. Um, when you're doing the, so you mentioned the mapping to like Cyrillic characters. Is there like an
Yeah.
initial pass through when deciding whether it could be gibberish or not by pairing up sets of characters? So if like GFH typically maps to PA, then you could say, oh, this has a higher likelihood of being Cyrillic combined because it has these 3 or 4 characters that are really common to like words
Yeah.
in Cyrillic. And then you get that.
So
Yeah.
no, I got you. I got you. That would be I mean, I'd like to know how Google is doing it to detect it. Since we're password cracking, it's super easy. I don't care about like statistically what is likely to be Russian given gibberish. We took English words, translated them, or even just took like Russian words, common Russian words, words we wouldn't have in English, and then transliterated them so that they're in ASCII, they're in a character that someone likely wouldn't have as their normal password, even if they just random generated it. And then if we crack the hash, or if we see that that password is in the Have I Been Pwned database and it's showing up 5,000 times, 10,000 times, 20,000 times, odds are that is a person who primarily speaks Russian and their password got transliterated, as opposed to 20,000 people all using the same random, like randomized gibberish 10 character password, and they got leaked. So it's a lot easier on our end because we're just cracking passwords, and we automatically transliterate it to see what's showing up often. So we don't have to deal with that. But yeah, and this, I guess, back to talk about how this affects our jobs and stuff. We're not going to commonly see transliteration all that often, because when we're cracking passwords, we're either cracking hashes that were leaked from a database, leaked from a web application that we managed to find a vulnerability on, or on an internal network with all the 20,000 different ways that we could get our hands on a hash. So I guess one of the big things that we're noticing, at least, we're getting our hands on more hashes from larger companies, companies that have different locations all around the world. So that's the reason like we started to do this research, I guess, is because we were getting more and more clients that have a lot of employees whose primary language isn't English. And how easy is it to find good word lists online for different languages? And a lot of it just ends up being, we're going to have to make them or utilize and leverage different common tools for like pulling down word lists off of Wikipedia for different languages, trying to get very specific words that you wouldn't traditionally find on like more common word lists, if that makes sense. I mean, Nate, I guess, how often are you cracking passwords and then you're going through and seeing that either they're like, this password should not have existed because it's weaker than what their password policy is, or we would have never gotten this password if we weren't, targeting this user specifically and like figuring out that kind of stuff.
Yeah, it wouldn't be a lot. And like it almost reminds me of really common sort of old school-ish way of building out those special word lists by using tools like Cool or Squeeze, right? Where you point it at a target web application, and then instead of using a standard word list that has normal dictionary words, you build your word list based off the words that are found on the website. So, for whatever reason, maybe the target company or the target application has a few words sort of strung together in a really unique way that you would never find in a traditional dictionary or common word phrase dictionary. But you know that now, and you do have access to that now because you built your word list based off a particular website. So it just makes me think of that, right? Like always specially tailoring your word lists and the way that you're going to crack a password hash given who you're specifically targeting. And I know we can talk about other areas and other pieces of input that go into building out that process. So you can download the words that are on a website, you can take into account sports teams, and then you do reconnaissance on somebody's birth year or things like that. And we can talk about that too.
Yeah, that's always like the very targeted stuff. And despite like a lot of enterprises, they have Enter ID, they can set a good list of custom banned passwords. I still see those all the time where like, just while we kick off like the kitchen sink attack, let's just try this big word list with this big rule list and let that run for a second off of like a bunch of hashes that we have. Even though there's like automated tools, I'm still finding myself like manually putting down company names, street names, like different internal names too that we found on the internal network. Like a company might refer to itself internally very differently, and like just looking at the domain name and that kind of stuff. and then just feeding that through like a leet speak transformer and then applying rules to that, that has gotten us like so many passwords. So like orgs really should be implementing that banned word list of you should not allow someone to put anything related to your company name in the password, because that's one of the first things I do, at least for trying to increase the number of hashes that we've cracked. That's like the first thing I go for after like the kitchen sink attack, trying passphrases, all that kind of stuff.
So okay, so here's a question then. What would, because my first question was going to be, what are some, maybe not red flags, but like what would be a beige flag for somebody who had a stated password policy, right? And we're all familiar with the normal password requirements and password policies, length, complexity, no use of seasons, those types of things. Would it be, would that raise your eyebrows more or less if in that password policy you saw don't use company name or any of its subsidiaries, right? Like, would that, because you're saying that's part of your MO, right? Is like
Mm-hmm.
you're going to take, regardless of what the password policy is, you're going to take the company name, you're going to do some modifications to it, and then you're going to use that in your cracking word list. I wonder if a company saying, hey, don't use the company name in your password would, I don't know, like, does that change the calculus at all?
Honestly, I'd probably still go for it personally.
Yeah.
If you asked me 2 years ago, 3 years ago, before we built our cracking rig, probably not. I would have been very hesitant to try things that might like take up compute time. But I mean, now that we've got the RTX 4090s, I'm happy to just ride through anything, brute force 8 character space for NT hash, just let's go for it. But yeah, no, the password policy does determine a lot about what attacks we should do and what's worth it. Like we shouldn't be wasting our time trying word lists with like there's a lot of different tools that you can use like pack2 I believe to filter down rule lists or build out specific masks that you want. And really quickly, like a mask attack is when we're using the tool hashcat to crack passwords and you're not feeding it a word list. You can build out a special set of rules to say I want you to try every character combination for 8 character passwords, 9 character passwords, or the first character should only be capitalized letters, just because that's super common for like corporate passwords. People will make the first letter a capital, it's a word, and then the last 5 characters are maybe symbol for numbers, or numbers ends in an exclamation point. So that's another way of us targeting those attacks. But if we know what the password policy is, and we know that it's actually being enforced even for like service accounts, which is something that often gets overlooked, or like local accounts, local administrators, sometimes they don't get covered by the password policy. But if we know the policy, let's say, is 10 characters, there's things that we can do to filter out anything shorter than that from our attacks, because otherwise we'd be wasting time. And there's a really good Git repo that has like efficient corporate masks, which just analyzes a lot of leaked passwords for people who work in enterprises, analyze what the most common formats are. So like I said, it's capital letter, lowercase, 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 up until maybe like 8 characters, and then the last 5 or the last 6 are like symbols and numbers. It basically does that, and then it'll just go through every combination of those, and that gets us a lot of passwords. So yeah, the password policy does in some way inform the types of attacks we do. But at the end of the day, I'll still try everything just because you never know. I think we do have a question in the chat. At what length does a password get notably more difficult to crack? Okay.
It's a pretty common
So
question, I feel
yeah,
like.
yeah, yeah,
Yeah.
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 Oh yeah. We've all seen the chart, like the little red, yellow, green chart where people are like, once you get to 16 characters, it's going to take the hacker 1,000 years or 10 lifetimes to crack the password. All of those charts are always if they're raw brooding the entire character space, like trying every possible combination of 16 characters. And it also depends a lot on the hash type. If your company has had a breach and you were using like um, a really good hashing algorithm like bcrypt, it's probably going to take them a lot longer to raw brute 8 characters than if we were on an internal engagement and we have like an NTLM hash or a hash that was stored on in memory on a Windows device. So depends on the hash, but at what length, I think because we primarily deal with both either bcrypt from leaked databases or internally NTLM, NTLM-v2, Kerberos. Anything after 8 characters is obviously going to get a little harder, but for organizations that have the 15-character password or 15 or 16-character password policy, we can still crack passwords, and we still do often. That just changes what we try to do. But anything you can do to throw the attacker off, anything like length is probably the best way to add complexity to a password, other than adding complexity by changing the characters and stuff, because we can always do passphrases attacks. Just making it longer is a good thing, but if it's a common phrase, we can still crack it. I realize that's not a real answer. I'll say anything after 14 characters is when I start to try very specific things, and also trying to do mask attacks for 14 character plus passwords basically makes our network closet turn into a sauna. So I try to avoid that.
No, I
14
think
characters is like the spot where I'm like, this is going to be tough.
that's a pretty good, I think that's a really solid answer. And like you said, right? We crack passwords that are longer than 14 characters all the time. I'm not sure what our internal record is. I'm sure there's all different types of records, right? But we do. But I think to JP's, one of the main points that, we as pen testers and security practitioners as a whole, what we're always trying to drive, right, is slowing down the attacker, making our lives as difficult as possible, and raising the barrier to entry on uncovering that plain text password. And so we can still do it when you've got 14, 15, 16 characters. It's just we're probably going to go after the password that has 8 characters instead. We're going to do that first, right? We're going to take the path of least resistance. We're going to find the lowest barrier to entry first. All other things being equal, then that's when we have to start getting unique, like JP said, with the mask attacks or coming up with sort of these other exotic type of password cracking techniques. So, but I think 14 is pretty good. I would also be really curious to hear or to really see some data on ourselves internally, but also maybe just across the industry, how that has shifted over the years. And then you can, compare that with things like the cost of computing, the cost of GPU cycles, the cost of, or the implementation and the adaptation rate of using secure password hashing algorithms in popular software, right? Because, like, if you do and look up how to code a web application in PHP today, you're going to get really different results, or in Java, you're going to get different results today than what you would 5 or 10 years ago, including the different types of password hashes and the algorithms used to store those password hashes. We probably cracked more passwords in the past, right? But is that offset by the cost of GPU reduction? That's probably a whole other talk and whole other area of research, but that kind of made me think of that.
Yeah.
Is that I mean, would you have any initial thoughts on, like, do you think we're getting better at password cracking, or are we not able to keep up with the pace of forcing common band passwords and things like that?
I think I don't know, right off the bat, Will, it sounded like you maybe wanted to say something too, but I think like the Entra bans, that mostly affects like password spraying, like our ability to go after commonly guessed passwords, because when we're cracking them, we're going through so many iterations that it almost isn't a factor. It's not going to be harder to get better word lists. Getting like sourcing word lists and creating different rules and masks on its own is like its own beast, its own skill. I'm not sure how that has changed with time. Obviously, we have gotten a lot better at password cracking just because compute hardware has gotten so much faster, in my opinion. And I just checked, the record was like 35, 36 character passwords. And it's a mix of people saying the same phrase 4 times or literally typing out the alphabet and then every number. So I don't know whose password that is. That took you way too long to type out personally, but no, that'd be really interesting to see like how well, we're obviously going to get it's going to make it easier for us to crack passwords because we can go through so many more options in such a fewer time. Like now with the number of GPUs that we have, we can brute force the entire 8 character space for NTLM in less than a day. So that is going to weed out those smaller passwords. As it gets better, we're going to be able to do that maybe for 9 characters or 10 characters. Like we can do that. It's just going to take an unreasonably amount of time or an unreasonable amount of time to do it. So I think it's going to shift towards length is still probably one of the most important things ever, but also it has to be complexity. Like what if your company's name is just really long and we guess company name 1 exclamation point? At that point, yeah, that password could have been 19 characters long, but it's also the first thing we're going to try by password spraying. And when we're password cracking, yeah, it's going to get there eventually. So, is there another question? Do you still run into things like password one? Yes. I'll tell you right now, yes. And we see it a lot with like, I guess, local accounts too, or sometimes service accounts that don't get covered by the password policy. You'll see like as we're going through and doing like stats on all the passwords that we've cracked on an internal environment, you'll see a couple passwords from the users starting to come in, and they're all really long, really like what should be complicated passphrases, but we were obviously still able to crack them. I see mostly passphrases coming from the users. Maybe we're not getting anything from like the higher privileged accounts, but then I'll see service, like a service account that's like using a scanner. Maybe it's like a Rapid7 service account and the password is scanner 123, because they're like, who's gonna, everyone needs this password or someone needs access to this password. They make it something super simple that isn't covered by the password policy for some reason. And then we can leverage that because the service account ends up having like a significant number of privileges that standard users account won't. So we still see that a lot of the time.
We've got another really good question from
We got two.
yeah, these are good. So the
One of
first
them was
question that
even
came in was when would be a good time to use a rainbow table rather than a word list when doing
so
password cracking?
yeah. Um so there are people, we don't really do it as much. The people who will pre-compute passwords with a word list or with a rule list to have that set so that you can run it through that instead of having like Hashcat go through it and run those iterations because it'll be faster. If you can just find the hash on a pre-computed list, it'll be faster. That doesn't really work with like salted hashes. That won't work with like NTLM-V2 because it's unique every time. You can have 2 hashes that look completely different, but it's the same password. So we don't do it as much. If you're ever at DEF CON and you have like a 10 terabyte hard drive, they will, you give it to them, and then 24 hours later, they will fill that up with like a crazy list of hashes and rainbow tables. So you can do that if you really want to. But yeah, I don't think we do a lot of like pre-computing word lists, not like that, like applying rules to it personally. And then to the other question, what
Yeah,
do you think of the
really
new NIST
quick, JP.
guidelines? Oh yeah, sorry.
I wanted to say I think that and without having a ton of data really to go off of, but I think a big just a general vibe over the last 5, 10, 15 years, rainbow tables obviously used to be that was sort of state of the art password cracking methodology, right? When people figured out like, oh, okay, to speed up this password cracking process, we can just pre-compute these lookup functions and then do it that way instead. And and this is where I'm finding some interesting things just to think about, like, I wonder if the the general community guidelines and push towards making passwords more complex, and the industry following security best practices kind of drove the state of the art password cracking technique sort of out of favor, right? I mean, and one of the reasons why JP just very briefly mentioned it, but why one of the biggest downfalls, at least in my experience of rainbow tables, is having a hashed or a salted or a peppered password hash will completely render at least that particular entry in the rainbow table completely useless. So it can be the same password, you have a different hash, or you do some other thing that goes before the generation of that password hash, and now that lookup function that's taking up, three kilobytes in your rainbow table is completely useless. And
Yeah.
but for the longest time, we as part of the industry would say you should be salting your passwords. You should not be storing them. You should be doing these things. And then as the industry progressed and as people started following those recommendations, password or rainbow tables sort of fell out of, I'm not going to say fell out of favor. They're still useful in their areas, but I think when we're talking about, the scope here, internal network web applications, for the most part, rainbow tables are not really as effective as, some of the work that JP's done and just some of the other work that's come out of, crack rates and other GPU improvements and stuff like that. So that's where I was just kind of wondering, or it would be interesting to think, did we as an industry push rainbow tables out of favor because we were successful in saying you should do these things that eventually led to their
Yeah.
demise, so to speak?
Yeah. Real quick, just because we're coming up on time, I want to address a couple of last question here I see. What do you think of the new NIST guidelines saying not to change password unless indicator of compromise is found? You guys want to answer that? Because I have an opinion, but
Sure. Yeah, I think this is in cybersecurity, this is the never-ending argument, depending on who you ask, like whether you have the 90-day password policy where you have to change it and it forces people sometimes to do very small iterations on the same password over time, which doesn't really do a whole lot of good, in my opinion. I was always a huge proponent of, like you've mentioned, JP, and everybody, Nate's mentioned this too, like long, 16 or more character passwords that have complexity to them, and using the, very secure, proper hashing algorithms. If you do in your, practicing these best practices, the likelihood of, something getting cracked is a lot less likely, rather than having, like a 8 character password or something like that minimum, and then you're just iterating it very small, amount of characters over the course of every 90 days. So I'm a huge proponent of this change. If you know your company is doing the right thing, there shouldn't be a whole lot to worry about, compared to previous. But I'm curious what your guys' opinions are. Like I said, never ending discussion here on this topic specifically.
yeah. I think it crazy answer. I think it depends, but there's some good to forcing the users to change the password. I think it all depends on how they're implemented. Like I've seen organizations that will force them to change every 30 days, which is ridiculous and is basically asking for the user to create something simple. Because if the user's not using a password manager, they're going to go for convenience over security. They're not going to prioritize that. They're going to come up with something that's super easy to remember. And every 30 days, they're probably just going to change it to like January or 1, 2, 3, 4, 5, 6, 7, and then pick something else. That's something else that we didn't really like talk about as much. But like when we, dump a did file, we also dump like the history to see if we can crack old passwords that a user has had, because then we can see, okay, are they just changing a number or are they genuinely changing the whole password every single time they're forced to change it? And the more frequently they're forced to change it, more than likely their password's going to be like Ronald McDonald 1, Ronald McDonald 1, 2, Ronald McDonald, like that kind of stuff. They're going to do it sequentially. They're going to change a single character. And where that becomes a problem is you don't always have an indicator of compromise. The amount of time it takes for you to realize that your credentials have been leaked to the internet, you don't know how long that's going to take. They could be leaked. Someone could have had them. Someone could have cracked that hash. Even if it's an old hash, if the user is constantly changing their password because they're being forced to, the attacker is going to be smart enough to figure out what the next in that sequence could be. And by then, you've been pwned by like cred stuffing. So crazy answer. I think it depends, but I think there should be some cadence to changing it. But again, it all depends. If you can't make a user change their password too much, otherwise you're going to make yourself more vulnerable. All right. One last question, and I think we should probably wrap it up because we are 5 minutes over. Do you have a good source for rainbows and or word lists to add to your? Okay. Not for rainbow tables. There is, if we're just strictly talking about NT hashes because they're not salted. Crack.sh is a service that went down a long time ago. So there is a website called ntlm.pw, which lets you sort of look up NT hashes in a very similar way. I don't think you can pull down their database, but you can just do a quick lookup there. And then for sourcing word lists, there's so many places. So let me pull them up real quick to add. I'll just add two in. First one is HashMob. HashMob is an awesome community of amazing password crackers. They are super cool. Everyone in their Discord is so good at this stuff, and they are constantly releasing, I think like maybe twice a month, word lists that come directly out of hashes that they've managed to crack that are out there in the wild, that are from either leaked databases or created by specific users for, I don't know, stress testing their GPUs or something. But I'll drop this right here. They have a lot of different kinds of word lists. And then the last one, they just got an update. It's weekpass.com. I believe they just dropped like weekpass version 4. They have tons of word lists that are like 100 gigabytes in size. So you'll find a lot there. If you have a computer that can run that, I don't know. We'll see. But they have a lot of different word lists tied to specific things. So they have word lists for cracking like WPA handshakes. So they have word lists because the way that people will create passwords for Wi-Fi is super different. So context is another thing that plays into the whole what word list should I use? And that's a huge repository of word lists. I believe they started ranking them too, like assigning them a grade value. So if you go there, of course, they put their own word list as S rank, and then they put RockU at like RockU 2021 is S rank. Okay, ignore that. That list is horrible, actually, but that's a really good resource. They probably have like hundreds of word lists you could pull. But yeah, hopefully that answers your question. And I think that's all the time we have. But thank you guys so much for showing up for this, hearing us ramble about password cracking for a bit, and I hope you learned something.
Yeah, sounds good. Take care, everybody. Happy Friday again.